Good morning. Today we're going to be talking about section 6.3 in our text, which is entitled Adding and Subtracting Rational Expressions. Well, as we know, rational expressions are really fractions. They're fractions made up of polynomials. So we can claim that adding and subtracting rational expressions is much like adding fractions. Of course, things are going to get a little more complicated. When we're adding fractions, for example, 1/6 plus 2/6, if the denominators are the same, of course, we just add or subtract the numerators as indicated, and 3/6 reduces to 1/2. So, not such a big deal if the denominators are the same, as we know. If the denominators are not the same, well, you've got to look for an LCD. That's the least common denominator. It's the least quantity that contains both denominators as a factor. The LCD, of course, here is 15. Well, forgive me if I'm belaboring the obvious. To get an LCD, to get a common denominator of 15, I'm going to have to multiply 1/5 by 1 in the form of 3/3, so I don't lose equivalency, and that turns into 3/15. And I will then also have to multiply 2/3 by 1 in the form of 5/5. Again, so I don't lose equivalency, I'll just alter my expression to be equivalent but with common denominators. Alright, once I've established the LCD and made the proper adjustments to each fraction, I can then add or again subtract the numerators as indicated in keeping that common denominator. Alright, nothing new there. That's a fraction arithmetic review. Well, we're going to be dealing with polynomials here now. Ratios or fractions built up of polynomials. Well, for example, let's start out nice and easy. 4/3x is a rational expression. 7/3x is a rational expression. And once the denominators are the same, we'll just add the numerators as indicated and keep my common denominator. Right, not such a big deal on that one. Well, maybe a little harder. X squared over x squared minus 1. That is a rational expression. Minus x over x squared minus 1. Now, the bad news, these are rational expressions that are being subtracted. The good news is the denominators are the same. So I can just add, or of course subtract, the numerators as indicated and get this resulting expression. Now, we can't stop here. You have to make sure your answers are completely simplified, and I can see each of these, both numerator and denominator, factoring, and we should always endeavor to factor all our polynomials into prime factors and look for cancellations or cross cancellations as needed. Alright, we can see a common factor of x minus 1 in this rational expression, and of course that reduces to x over x plus 1. Again, that's my final answer, and again, please don't cancel out those x variables in that final answer. Okay, let's try another one. Well, what about when the denominators are not the same? Well, let's see. 3/x plus 4/y. Well, I suppose the first step here would be to spot an LCD. Now, the LCD, the book gives a formal definition of the LCD. Let me try to get a more informal definition. It's the least quantity, or the smallest quantity, that contains all factors of all denominators. I'll just abbreviate denominators as denoms, if that's alright. Alright, well, what is the LCD for this problem? For this example, the LCD would be x times y. That is the smallest quantity that will contain as factors each of the individual denominators. Alright, so what I'll need to do here, I'll need to make some adjustments to each of these rational expressions. To get a common denominator of x times y, I'll multiply by 1 in the form of y over y. I'm multiplying by 1 in that form so I don't lose equivalency. Similarly, here on this second rational expression, I'll multiply by 1 in the form of x over x, again so I don't lose equivalency. So I end up with the equivalent expression 3y over x times y plus 4x over y times x. I'll write as x times y. Alright, now I do have a common denominator in both of these rational expressions, and I can just add or sometimes subtract as indicated. 3y plus 4x over x times y. So it may get a little sticky in some of these harder problems in establishing an LCD and making the necessary adjustments to express equivalently with an LCD. Let's do another one here. Example, I'll say this one's a subtraction. Subtract the following rational expressions and of course simplify your final answer. 4x over x plus 2 minus 7x over x minus 2. Alright, I suppose the first thing I should do is try to spot an LCD. Well, again, the LCD is the smallest quantity that contains all prime factors of each denominator. Well, notice, this denominator is already prime, can't be factored. This denominator is already prime, can't be factored. So my LCD is going to contain the product of x plus 2 times x minus 2. Remember, the LCD is the smallest quantity that contains as factors all prime factors of each denominator. Alright, so let me rewrite this for a minute. Alright, so if I want to change these denominators to look like my LCD, well, I'm going to have to multiply by the missing factor here. In this first rational expression, I'm missing x minus 2, so I'm going to multiply top and bottom by 1 in the form of x minus 2. Similarly, in the second rational expression, in the denominator, I'm missing an x plus 2, so I'm going to have to multiply top and bottom here by x plus 2 to get an LCD and to maintain equivalent expressions. Alright, so upstairs I'll have, well, if I'm going to multiply x minus 2 times 4x, I'll get 4x squared minus 8x, will I not? And downstairs, I'm just going to leave it factored. I'll write it as x plus 2 times x minus 2. Right, multiplying x minus 2 times x plus 2, right? Second expression, 7x times x plus 2. I have to apply my distributive law. And notice this subtraction here, probably a good idea to wrap this second numerator in parentheses because you're going to have to carry through that negative sign. 7x squared plus 14x would be my resulting second numerator, divided by, of course, I'll write it as x plus 2 times x minus 2. Remember, multiplication is commutative, and you can change the order of multiplication and retain equivalency. Alright, you're going to have to subtract each term of this second polynomial from the first. Well, 4x minus 7x squared will give me a minus 3x squared. And I forgot to mention, notice these denominators are the same. Please notice the denominators are now identical, so I can add or subtract the numerators as indicated. Okay? So 4x squared minus 7x squared will give me a negative 3x squared. Be careful of this negative sign here. And minus 8x minus 14x, that'll give me a negative 22x. You've got to carry that negative sign, this negative sign, through each term of this second polynomial, the second numerator. So I'll get a numerator of minus 3x squared minus 22x, and of course a common denominator of x plus 2 times x minus 2. Alright, that top numerator, the numerator in this expression is prime, so cannot be factored. Well, not meaningfully anyway. I could factor out an x, but I wouldn't be able to get it to cancel out with anything in the denominator. So I'm going to leave this. I'm going to claim this is a completely simplified answer. Can't break it down any further, at least not meaningfully. Alright, so we're climbing up the ladder with our degree of difficulty here. Add and simplify. Alright, this sum of two rational expressions, well, you could make this a nasty problem if you don't notice something. Do you notice anything about these two irrational expressions? In particular, do you notice anything about the two denominators? X minus y and y minus x are opposites, similar to a claim we made in the last section of this chapter. And if they're opposites, well, that means you just have to multiply one of them by -1 to get a LCD. Well, let's see. I'm going to take this second rational expression. I'm going to multiply top and bottom by 1 in the form of -1 over -1. And I think why we do that will become clear in a minute. First one I'm going to leave alone. Well, y times -1 is -y in that second numerator. Downstairs, if I multiply y minus x times -1, I'll get -y plus x, which of course is equivalent to x minus y, is it not? Alright, so recognizing the original two denominators as opposites really helps us along quite a bit here. Alright, so I now add or subtract these numerators as indicated. I'll get x minus y over x minus y, and if I've got identical expressions across a fraction bar, of course I can cancel them out, and this problem reduces to the number 1. Remember, when you make a cancellation, a factor of -1, a factor of +1 appears, and hence reduces to, in this case, 1 over 1, or just 1. Alright, let me get a fresh screen. Well, let's try another one. Add and simplify the following two rational expressions. 5a over 24b plus 11a over 18b squared. Alright, so monomials in each numerator and denominator, so we don't really have to factor anything. I do need to spot an LCD, though, to get a common denominator. Can you, by inspection, spot the least common denominator, or I really should say the least common multiple? Many books use the phrase LCD or LCM. They both mean the same thing. The least common multiple or the least common denominator. It's the smallest quantity which contains all factors of each denominator involved. Well, you'll have to ask yourself, what's the LCM? What's the least common multiple of 24 and 18? I had to think about this for a minute, and I believe I came up with 72. The LCM of those two coefficients is 72, and let's see, what's the least common multiple of b and b squared? Remember, the LCM is the smallest quantity that contains all factors of both denominators. Well, I claim b squared contains both b squared and b as multiples, so I claim this is the LCD, 72b squared. Well, clearly I'm going to make some adjustments here. This first rational expression, if I multiply both sides, or top and bottom, by 1 in the form of 3b over 3b, I will then get a equivalent expression with a denominator of 72b squared, and that's what I'm looking for. On the second rational expression, I got 11a over 18b squared. I'm going to multiply top and bottom. Well, I don't really have to add a factor of b here. All I need to do is multiply by 4. Top and bottom by 1 in the form of 4 over 4. And then complete that multiplication. I'll get 15ab in the first numerator divided by, guess what, 72b squared in the denominator, plus the second rational expression will turn into a 44a on top divided by, of course, 72b squared in the denominator. Alright, once I've established an LCD and once I've adjusted the two rational expressions to have a common denominator, then I can add those numerators as indicated, and I'll get 15ab plus 44a divided by 72b squared. Alright, I'm going to call this a completely simplified answer. If you'll notice, in that numerator I can factor out an a, but I see nothing to cancel it out with in the denominator, so I'm going to claim for our purposes that's a completely simplified answer. As we'll see in later examples, there may be times when you can simplify a bit further. Okay? Add. Actually, this one's a subtraction. Subtract. And simplify. Get x plus 1 over x squared minus 2x plus 1, and from that rational expression we want to subtract another rational expression, x minus 4 over x squared minus 1. Alright, so our first step should be to identify a least common denominator. And again, the least common denominator, or least common multiple, contains all factors of each denominator. So clearly we've got to factor these denominators to be able to spot the LCD. So that's going to be my first step here in this problem, is to factor each denominator. Well, x squared minus 2x plus 1 factors as x minus 1 times x minus 1. And the second denominator is, of course, a difference of squares, and that'll factor as x plus 1 times x minus 1. Alright, now I have to spot the LCD. Now remember, the LCD, or LCM, same thing. It's the least quantity that contains all factors, all prime factors of each denominator. Well, here I've got two factors of x minus 1. Here I've got a factor of x plus 1 and a factor of x minus 1. I claim the LCD for this problem. Well, you'll need two factors of x minus 1 and one factor of x plus 1. Alright, so please convince yourself that this expression contains all factors of both denominators. Alright, so I'm going to have to make some adjustments here. There are some missing factors in both of these denominators. Let me rewrite this top line of code, and then I'm going to throw in the missing factors that are needed in each rational expression denominator. Alright, to get this to look like this, I'm going to have to throw in a factor of x plus 1. So I'll multiply top and bottom by 1 in the form of x plus 1 over x plus 1. Similarly, over here, this denominator is missing a factor of x minus 1 that we need it to look like this. So this expression I'm going to multiply by 1 in the form of x minus 1 over x minus 1. Alright, so these can get nasty. There's a couple even nastier ones coming up here today, so be sure to show good housekeeping. Alright, multiplying these two numerators. I'll get x plus 1 times x plus 1. That gives me x squared plus 2x plus 1. Does it not? And downstairs, well, again, I can rearrange the order of the factors any way I like. I'll get x minus 1 times x minus 1 times x plus 1. Okay? Multiplying that expression by the existing denominator. Minus, hang with me here, multiplying top and bottom by x minus 1. And again, don't be careful about this negative sign here. Probably a good habit to get into is wrap your result in parentheses. I need to multiply x minus 4 times x minus 1, and I'll get x squared minus 5x plus 4. And downstairs I'll get, well, x minus 1 times x minus 1 times x plus 1. Again, I can rearrange those factors any way I like because of commutativity of multiplication. Alright, so I spotted the LCD. I multiplied by the missing factors, top and bottom, in both rational expressions to get an equivalent expression with LCDs as denominators. Now I have to subtract. I'm going to take this polynomial minus this polynomial to get a new numerator. All right, well, of course, x squared minus x squared will cancel out. 2x minus 5x, be careful of that negative sign, is going to be minus or plus 7x, right? Check it. 2x minus 5x will be plus 7x, and of course 1 minus 4 gives me a minus 3. Alright, so subtracting my numerators as indicated results in a new numerator of 7x minus 3, and of course my common denominator will be my new denominator, x minus 1 times x minus 1 times x plus 1. Alright, I call that a completely simplified answer. The numerator is prime. The denominator is already factored into prime factors. There's nothing I can cross-cancel across that fraction bar, so I'm done with this problem. Alright, the next one, I think I might need a new screen for this next one. It's kind of a nasty one. Here we go. Again, it's mixed operations. I can hear your groans already. Well, mixed operations means we're going to be doing both addition and subtraction. Hang on. Alright, my tablet burped for a minute. Hang on a minute. Mixed operations. Alright. I have to write smaller here. This one is going to go on for a little while. I've got 2 over x squared minus 4, a rational expression. From that, I want to subtract another rational expression, x squared minus 1 over x squared minus 3x plus 2. And to that, I want to add another rational expression, x plus 1 over x squared plus x minus 2. Alright, my first step should be to identify an LCD, a least common denominator, and then multiply as needed to convert the expression equivalently with our new LCD. Alright, to that end, of course, I'm going to want to factor each of these denominators. And the first denominator factors is x plus 2 times x minus 2. This second denominator will factor as x minus 1 times x minus 2. And this third denominator will factor as x minus 1 times x plus 2. So I've completely factored each denominator. My next step will be to identify the LCD or the LCM, the least quantity, which contains all factors of all denominators here. Well, let's see. I think I can spot this pretty easily once I see the prime factors. I claim my LCD is going to be x plus 2 times x minus 2 times x minus 1. Alright, I can see this denominator is missing an x minus 1. This denominator would be missing then an x plus 2. This denominator would then be missing an x minus 2. If I can throw in equivalently the missing prime factors here, I can get all three of these denominators to look like this. Okay, of course I'm going to have to make adjustments to my numerators as I go along here. Alright, I'm going to try to write small here and keep things organized. I'm going to multiply this first expression. I'm going to multiply top and bottom by the missing factor. Well, for this one it's x minus 1. There's no x minus 1 in the denominator. So 2 times x minus 1. Hang on a minute, I think I made a mistake here. Oh yes, please make this correction. There's a copy error. It doesn't really affect anything we've done so far, so I'll throw in the correction here. That first numerator is a 2x, not just a 2. So please make that correction. Doesn't affect our denominators, at least not yet. So multiplying top and bottom, this first rational expression by x minus 1, okay. Alright. Now I'll move along to the second rational expression. What missing factors do I need in my denominator in the second rational expression? Well, of course, it's x plus 2. I have to multiply top and bottom by x plus 2. Well, there's only a 1 sitting in that numerator, so 1 times x plus 2 is just x plus 2. And downstairs, of course, I'll get x plus 2 times x minus 2 times x minus 1. Again, rearranging the factors in that denominator as needed by commutativity of multiplication. And how about this third rational expression? Well, what's the missing factor in this third denominator? Of course, it's x minus 2. So I'm going to multiply top and bottom by x minus 2 in order to get equivalent expression with the correct common denominator, right? Alright, so I've written as small as I can here and try to take my time. Alright, I think the worst may be over. Now I've got to multiply the numerators together in order to add or subtract the numerators as needed. Alright, so let me, well, you know what I'm going to do? Just to save time and space here, my numerators are all the my denominators are all the same here. So what I'm going to do is claim my common denominator, and I'm going to multiply these and negate these numerators as indicated. Alright, 2x times x is 2x squared. 2x times minus 1 is minus 2x. Takes care of the first numerator. Let's move on to the second one. Negative, be careful, you have to negate this entire sum. Carry that negative sign through. Minus x minus 2 plus. Alright, now I've got to multiply this out. X squared minus 2x plus 1x is minus x minus 2. Alright, so now it's a simple combination of like terms to arrive at a final answer. Well, let's see, 2x squared plus x squared is 3x squared. Takes care of those two. Minus 2x minus x, that combines to minus 4x, so I'll knock these away. And minus 2 is minus 4. Don't forget to keep your common denominator that we work so hard to get. Alright, the worst is certainly over. I think I see this numerator factoring, and that can happen sometimes, so we always should strive for a simplest possible answer. Alright, if I get 3, and looking at the numerator, if I get 3x and x in the first slots, I think I see something happening. Plus 2, minus 2, let me check it. The outer product is minus 6x, the inner product is plus 2x. Yes, that works. And I do see a common factor now of x minus 2. So I'll get 3x plus 2 left in my numerator, divided by factors of x plus 2 times x minus 1. So those mixed operation ones are a little rough, as you can see. Let me scan up above. We started with something that looked nastier. It even looked a little nastier as we progressed through the problem, but sooner or later we got things to line up correctly and make some nice cancellations to get a reasonably simple final answer here. So beware on those mixed operation ones. They're coming up. Alright, let me try another one here. I believe this may be the last one, and it is more or less of similar difficulty as the last one, maybe not quite as bad. Let me write it out here. Subtract and simplify. We're going to take one rational expression and subtract from it another rational expression. Alright, so, well, here we've only had two. We only have two rational expressions to deal with, and last one we had 3. So maybe it's somewhat easier. Well, first step is to find at least common multiple, at least common denominator. And again, the least common multiple contains all factors of both denominators here, so I'm going to have to factor each denominator. Alright, so 2x squared minus 5x plus 2 reduces to 2x minus 1 times x minus 2. And minus 4x. Hang on a minute. 2x squared minus 5x plus 2. Yeah, that works. 2x squared minus 4x minus 1x is minus 5x plus 2. Yeah, that works. Alright. Let's factor the second denominator. And I'll get x and x in the first slots. 2 and 1. Let's see, I think I see it. Plus 1 minus 2. Let me check it. The outer product is minus 2x. The inner product is plus 1x. That works out okay because the minus x inner and outer sum, and the last product is negative 2. So that works also. Alright, so I factored each of the two denominators, and again, I need to spot the LCD. Now the LCD, which is the same thing as the LCM, the least common multiple, contains all factors of each denominator. So my LCM has to have a factor of 2x minus 1. Well, you know what I'm going to do? I'm going to order it like this. My LCD must contain a factor of x plus 1. It must also contain a factor of x minus 2. And I see x minus 2 is already included here, so I don't have to include it again. And I also must have a factor of 2x minus 1. Sorry about crowding this in on the right. Alright, so I claim this is the least quantity that contains all factors of each denominator. So I'll need to make some adjustments as I express equivalently with a common denominator. Alright, so I'm going to take this first expression, multiply top and bottom by x plus 1, which I can do to maintain equivalency. On the second rational expression, I'm going to multiply top and bottom by 2x minus 1, because that's the missing factor in my second denominator. Again, it's a good idea to wrap your existing numerators in parentheses, as I've done here, as you can have to perform some operations on them. Alright, let me go ahead and multiply that first numerator now. I'll get x squared plus 4x plus 3 divided by my common denominator. And again, in that denominator you can arrange these factors in parentheses any way you like by commutativity of multiplication. Minus, and be careful, again minus, you're going to have to carry that negative sign through whatever appears in your numerator. If I multiply these two binomials in the second numerator, I'll get 6x squared minus 5x plus 1 divided by, again of course I've got a common denominator, x plus 1 times x minus 2 times 2x minus 1. Alright, I'm hoping the worst is over. Now I've got a common denominator in both of these rational expressions, and I can subtract those numerators as indicated. Well, x squared minus 6x squared gives me a minus 5x squared. Be careful of this negative sign again. 4x minus 5x, minus a minus 5x. I drew a circle around that and it looks like a plus sign. This was originally a minus, right? Let me do that again. 4x minus 5x gives me a plus 9x, does it not? And then of course 3 minus positive 1 gives me a 2. Alright, so I've subtracted the numerator polynomials as indicated, and of course I'll keep my common denominator. And I think I see that numerator polynomial factoring, but I see a lead coefficient that's negative. What I'm going to do is always easier to factor when you've got a positive lead coefficient. So what I'm going to do is factor out a negative 1 from that numerator to express it equivalently. Hang on, we're almost there. Alright, factoring this resulting trinomial in my numerator, I think I see a 5x plus 1 times x minus 2. Let me check it. 5x squared minus 10x plus 1x is minus 9x, and then minus 2. It looks good. Don't forget that negative 1 factor is still floating around upstairs. Alright, if I rewrite my common denominator, of course we see now easily that I've got a common factor of x minus 2. So I've gone as far as I can, and well, I suppose I could express my answer in one of several ways. Negative 5x minus 1 over x plus 1 times 2x minus 1. That's a fine expression of the final answer. I think our author would probably absorb that negative side, that negative sign, outside the division process. That can be done as well. So I claim either of these answers or anything equivalent and completely simplified would be fine. Alright, so some of these mixed operation ones, some of these with 3 factors in the LCD, they get a little nasty, folks, so be careful out there in the homework and also on your online exam coming up. Alright, we're hitting the 41-minute point. We'll call it a day. This concludes section 6.3, adding and subtracting rational expressions.